Welcome, everyone, to the plenary closing session of RDA 24, Fair and Care in AI. Today, we are going to be having two short presentations, and most of the time is going to be around Q&A. So this is Q&A around AI. This is Q&A around fair and care principles. What is findable, interoperable, accessible, and reproducible, especially not in that order, and care, so that are we acting for collective benefit? Do we have the authority to control? Do we have responsibility, and do we have ethics? How do these two paired principles work in an age of AI? Today, Amir is going to be presenting on his research on identifiers, and Susanna is going to be presenting on her team's her research in helping Indigenous communities with AI and the problems of consent and the problems of offline and the problems of remote, because all of those are quite a lot of problems. Again, since we have a bunch of folks joining us, please ask any questions that you wish in chat, and I will queue them up. If you have a question during Q&A, use the reaction to raise your hand, and I will ask you to unmute when we get around to you. And in the certainty of things going long, rather than taking up any more of folks' time, Amir, I would like to introduce Amir. Amir is Associate Professor at Swinburne. He leads the Social Data Analytics Lab at Swinburne University of Technology. The lab applies data analytics techniques for insights into health and social challenges. His expertise is in data modeling, information retrieval techniques, and real-time data analysis. In other capacities, Amir leads the Swinburne node for the Center for Information Resilience, an Australian Research Council Industrial Transformation Training Center. Amir, why don't you tell us about fair and care in AI?
Okay, thanks a lot. Thanks, Brian, for the introduction. Let me start by sharing my screen. So I believe everyone should be able to see the first slide. As Brian mentioned, my background is in kind of computer science, but I lead a team that they work with research data in different capacities. So in this talk, we are going to focus on the role of AI in research and research communication, but also I'm going to focus on one major question. How can AI basically help in making research capabilities fair? And I think from fair concept, I'm going to more focus on the findable and accessible and less about the interoperability of this. So in the current concept of generative AI, which is at the moment affecting all the research ecosystem, in the last couple of months, even just from 2025 January, we got one major development, which is deep search. If you're using ChatGPT, Gemini, Grok, Cloud AI, all of those tools right now have the deep search capability that help researchers to kind of do the literature review, not exactly, but to a great degree expedite that process. It's basically doing a major search across multiple repositories and then synthesizing the result. There has been, and there's a much more available tools around the summarizing the academic articles and research contents, like Notebook LM from Google is the example of this. But the other thing that is emerging more and more is that using the basically AI or generative AI for knowledge mining from research data. In this talk, we're going to focus on this part and with the focus on the research capabilities and how we can make those information more accessible. But a bit of background, I need to talk about the project that this whole activity are in that context. So ARDC during the 2022-2024 launched a whole new platform that's called Research Link Australia. The idea of the Research Link Australia, or RLA, as I'm going to call it for the rest of this presentation, is that it basically creates a bridge between the industry and research. So the intention behind this platform and all the capabilities are created in this space is aimed to actually make the researchers more accessible to industry partners and make industry, businesses, companies, government more enabled to actually find the right researcher to address their technology problems. So it's kind of filling the gap in that space of what we call connecting the dots. Now, RLA has an online portal that launched last year. It is quite a capable platform that provides information about researchers, organization, and research projects. You can actually find different researchers by basically searching topics, and it brings those researchers. You even find the related organization who participated in projects and projects by themselves. Behind this engine, there is a substantial graph database that read information from different persistent identifiers. So I'm assuming and kind of trust that as part of the RLA, you are quite familiar with the concept of PIDs. So they are kind of essential components of a lot of scholarly communication infrastructures. Now, in the case of RLA, the PID ecosystem is quite important, and ORCID is one of the major drivers in this space. So ORCID information provides a very, very usable platform, data capability, and also unique information about researchers and their research activities that then platforms like RLA bring it to the front. Now, but underneath of this, we also have a Crossref data side. I wouldn't go to detail of this, but RLA also use some of the information from Australian Business Registry that the mapping is done using AI technologies. But this in the core is a persistent identifier graph by harvesting information from multiple sources. So the other thing that RLA does, and I think this is the focus of our experiment, is that RLA also have projects, and one of those in the area of the health and well-being. So RLA project on the data community of practice for health and well-being was a partnership across multiple organizations. We had a diverse ecosystem of the medical research institutions, CRCs, not-for-profit organizations, and universities. And the idea was how we can actually map the research capabilities and connections and opportunities between the research and industry across diverse stakeholders in the health space. So the questions that has been raised as part of this group and then came out of multiple workshops, the focus of our work was looking at the identifying research capabilities in-house. That means what these organizations can do by their own team, but also research capacity, that they have their own collaboration network. These are the people who they collaborate with, they publish with, they get grants with. They're not directly employed by those organizations, but they are in their network, and that actually could provide quite a good opportunity to expand their technical or research capabilities in that space. The other questions is the potential research and industry partnerships, also learning from what the successful partnerships has already happened and what do we learn from those, and also the impact of collaboration. How do we quantify or qualify, even from that point of view, the investment that's gone to building these collaborations with all of these partners? So as part of this exercise, the way that we approach this, we basically assume that there are three different kind of pillars. There's the data that we are basically using as part of this project. There are domain experts that are essential component of projects like this. And then there's analytics capabilities. That's where AI comes to play. So the data co-op type activities are a lot around the workshops. And these are basically, if you can think about this, they have a flavor of co-design, but it's more data-driven. We will get the data from the partners about the project's activities, the fundings that they got, and the partnerships that they have. And then underneath, we have the RLA data, all the data information that I mentioned. Then our analytics capabilities look at all of this information, try to produce data insights. Those insights feed into these workshops, and then we learn from domain experts that what is and is not appropriate, relevant for answering what type of questions. The data that goes from the partners in this project or has gone is quite substantial. We were working with about 23,000 researcher information. So, but if you can think about this 23,000 profile of working researchers, we had about 3,000 grants and projects, more than 8,000 research outputs, publications, and close to 6,000 organizations who are in their network. So we were basically, if you like, this has been our playground, then augmented by the RLA information. So how do we answer the first question? How do we find research capabilities? Well, there's a manual way of doing this. In our workshops, we actually tested that. We got everyone to come up with their ideas, the sticker notes, we put them on the whiteboard, trying to find out or try to map the research capabilities and their network in that process. I can tell you it's not a very easy task. And even in a group that already have quite a good collaboration together, it proved to be quite challenging to map these things and come in with the agreement of how individual profile or capabilities should be kind of described. So that is where the AI is coming to play. So one round of activities that we did was getting all the project information, use AI technology, and then try to create the classifications. And we have done this multiple times, and each time getting the feedback from the domain experts in the room and trying to find out what is the optimum classification for this group, basically. Now, the kind of revised version and final version basically gave us 4 major categories. So we have identified that this group have expertise in health and well-being. That was also given. But then underneath, they identified that they have a physical health, mental health, and so forth. We have the social services and community support that describes some of the activities in this group. We have the environmental sustainability and innovation. There have been substantial portfolio in that space. And the technology and data science was also a descriptor of some of the projects in this space. So what we have done is that then we take them through our kind of insight engine, and we start exploring to see how individual groups look from that type of taxonomy in order to describe their capabilities. Now, this was one of those moments that we kind of felt that, okay, AI has done a good job. And that is kind of this diagram where we can see how different partners kind of portfolio can be compared with each other, looking at different capability kind of groups. So Origin, which is a medical research institute, have more than 91% of their portfolio in health, while the digital health CRC is about 24% health, but a lot of projects have the technology and data science capabilities built into it. I often get the question that what about a project that belongs to 2 different categories? That's in these kind of scenarios, we apply the most relevant category to that project. And hence, this project or this diagram can be plotted different ways if you want to include all the different dimensions of those classifications. But for the simplicity of that argument, we took the most relevant category. So now this is about a collective view. How about individual organization? And that's where things got more interesting and descriptive for each group. So if you only look at the origin, we use AI classification. Now we get much more than health and well-being. We get the classification across the digital and virtual interventions, the innovative therapies, and there's a whole category that goes to this. So if you think about that line, when we go into the detail of it, now there are 5 major categories, and underneath of this, there is those subsections that describe the group much more refined. And then in our visualization, you could kind of drill into this group and look at the projects and the project partners. The other thing that we learned as part of this exercise, which was given, obviously, but we felt that, okay, this is proof that the system actually works, is that the different groups have a completely separate portfolios that each one of them very well talks about their own project. So it's got kind of like this narrative all come together. Now, mapping this in the kind of collaboration network works in basically as a filter system. So using this capability, for example, for Origin, they have about 174 organizations across 20 countries in their network. But we could look exactly at what organization work on the youth mental health, and then map that network based on that particular concept, and what researchers are most active and what funding and partnership established in that space. Now, some of this information in those workshops actually enabled other partners to realize, oh, there are other funding opportunities or there are other partnership opportunities that we didn't know. So that groups also worked as a place for developing the network. So the other example of this one is industry government partnerships. And this is also another example of looking at those classification at the course grain. Here we have the main topics that we talked about: the health and well-being, technology, social services, and environment. And then focusing one of them help us to look at the global map of that ecosystem. So if I want to summarize what we learned from this activity, was from the AI point of view, the RLA workshops that we run was heavily driven by enabling these kind of visualization, which was incredibly enabled by AI analytics. And one element that came to this conversation was, in some way, AI guided some of these discussions or facilitated those. While if we did in the past, we were doing the similar activities, but in a much more expensive way using the traditional machine learning. Now generative AI somehow expedite the process and make it much more accessible. So how all of these things means for research? I can summarize this by saying two ideas. I think this is some of the things that we learn as part of doing activities like this. One is, if you think about the augmented intelligence concept, that's the basically augmenting the domain experts with AI technologies. It opened in new possibilities that previously was out of reach, and that can become because of the cost or complexity. Now we can use this technology to do the things that previously has been quite a substantial undertaking. And kind of the final point around this is this enabling capability and capacity can make the research easier and make it more cost effective and make it more accessible. And this is not just about the partnerships in general. This is the trend that we see for a lot of researchers. These new tools are quite effective in making a lot of traditional laborious research activities, bring it to the point of, well, this is now business as usual, but very easy thing to do. Okay, so thanks a lot for this. If you need more information about two components of this talk, so the project website is on the page, and then the RLA link also is on the ARDC website. I believe you will have a copy of these presentations, so you will be able to click on those links. Thank you very much. And Brian, back to you.
Wonderful. So we have a few minutes as we transition slides, and I'm going to take prerogative as the moderator to ask the first question. For everyone else, please use the raise hand button in your reactions to queue up your questions or drop them in chat. So my first question, and I'm going to go super technical. How did you choose between open weight models? Because I saw that you chose Mixtral 8B. And more to the point, how did you evaluate your prompts?
So I'll answer this last one first. So the prompt evaluation was comes from two different kind of line. One is that our group uses generative AI for a lot of analytics. So we kind of develop the in-house expertise around the prompt evaluation, but that's not really the evaluation, it's expertise of prompt engineering. The actual feedback comes from domain experts in those workshops. So we learn from them that what works and what doesn't work. And that is a loop that takes us back to the kind of AI and help us to refine the message. On the picking of the open source models, I think it's an interesting question, because when we did the project, this was a major issue and makes one of the good ones on the market. Now it's not that much. Actually, we had a substantial development in the AI technologies. And these days, almost majority of the latest AI models released, they are highly accurate and highly capable. And I'm running some of those things in my Mac notebook for kind of day-to-day driving activities. Gone the days that we try to shout at the LLMs to say, please give me this file in JSON, and it just keep ignoring you. So now the technology has improved in a great way.
Excellent. I don't see any hands raised, so I'll keep asking you questions. Since this panel talks about fair data, is your data that you produced from the outcome of this analysis, or more to the point, your categorization code, published anywhere?
Yes, so the data is accessible in two different kind of three different areas. So the data is accessible to the RLA platform. So ResearchLink Australia makes all of this data accessible, and there's a machine readable interface underneath that you can fetch the graph and all of this information. The detail of this all published in Zenodo, and also a copy of this graph, although being an RDA closing plenary, I say don't quote me on that one, it really doesn't make me any favor. But the plan is that we also publish a copy of this information in Australian Data Archive as a graph.
Excellent.
So just the annotation part of the data. But yes, definitely the FAIR part has been the kind of the embedded in our ecosystem.
Excellent. So we have a question from the audience. Do you use RAID as a choice of PID for your output?
Well, RAID is for project activity. So there are two ways of answering that question. The whole thing that we did can get a RAID as a project, obviously. But there is also another angle of looking at this. I'm not sure that question would kind of consider this, but I'm going to kind of use this opportunity to open that. There is a lot of projects in these ecosystems that do not have a grant ID or public front end page. So these are information, a lot of them are contract research. And there is a very, very good and unique opportunity for RAID to play a role of creating the unique identifier for those projects that are not publicly funded, but they need to be identified for projects like this.
Wonderful. I think I'm going to keep pushing the time just so that we have more time for Q&A at the end. Do you have any closing thoughts or comments before we swap over?
No, I just want to expand more on this whole RAID concept. So we, in one of the working groups, we talked about this, the role of AI and PIDs. And one of the essential importance of what the main ingredients of projects like this is a persistent identifier ecosystem. Now, obviously, AI provides, like this presentation, provides capability of reading information out of this graph. But also, it is a very, very unique opportunity to enrich this graph with AI technology, and that provides value for everyone.
Wonderful. Thank you so much, Amir. And you will be back in about 20 minutes, joining us on a panel as we discuss various topics.
Thanks a lot.
I would like to introduce Susanna Soon of Curtin University. Susanna, let's get you unmuted. Welcome. Susanna is a research and teaching academic in computing at Curtin University. She delivers multiple multidisciplinary, demand-driven research projects using her expertise in AI, digital health, human-computer interaction, and product design and development. Wow, that's a lot of disciplines. Susanna leads the award-winning, high-profile flagship Healthy Connections project, developing a mobile medikit to improve health equity in remote and regional areas, such as Western Australia's Pilbara region. The medikit is AI-enabled and satellite-connected, enabling clinicians to take it on-country to provide preventative health screening for chronic conditions in remote communities. To open this conversation, I'll play a video that Susanna has given me.
Yeah, thank you, Brian. So fantastic to be here and able to address an international audience. I'd love to show you some of the work that we've been doing over the last 18 months with a really big team of about 30 or so students and staff.
Wonderful. Let's begin.
The Healthy Connections mobile medikit is transforming healthcare delivery in the Pilbara by enhancing accessibility and equity. This AI-driven, satellite-enabled screening tool is portable, allowing healthcare workers to bring the clinic directly to the community on-country. By facilitating on-site chronic disease screenings, the medikit helps prevent conditions such as heart disease, diabetes, and renal disease, ultimately improving health outcomes in these communities.
We're developing a medikit which would allow us to undertake point-of-care health assessments at events like the festival and in remote Mardu communities.
The medikit provides a whole-of-community, lifetime approach to reducing chronic disease in a culturally safe and appropriate way. On-country screening will allow us to identify people at risk early, provide education and connect them with health services and follow-up. This will help reduce the burden of chronic disease on Aboriginal communities.
One of the major features of the medikit is its portability. We can take the medikit to anyone's house, to a community, to an event. And this portability allows us to provide access to healthcare where it may not be possible before.
I'm a nurse out here in the Pilbara. Out here we have a variety of different clients, and for different reasons they don't want to come into the hospital and other health services.
So to have an all-in-one Medikit to take out to community actually helps me deliver kinship care in a much more accessible and equitable way.
The Pilbara is known for its natural beauty and rich resources. It's also home to traditional owners who experience some of the lowest health equity in Australia. By introducing this digital health technology, the Medikit will help close the technology gap for Aboriginal communities, empowering them with access to their own health data and fostering self-determination in managing their health outcomes.
We can add extra sensors and extra healthcare devices to the Medikit. This way we can expand the array of different services we can provide.
Community elders understand the importance of the Medikit, and they have told us they want it for their communities. They've invited us to work together to bring the Medikit to improve healthcare outcomes for future generations. We invite you to join us on this healthcare innovation.
So thank you very much for watching that. I'm just about to share my slides. Looks to me like they're sharing, and I'm just going to go full screen. So does that appear?
We have your presenter view on that one.
So you have the full screen?
Unfortunately, we have no, we don't have the full screen.
You've just, so I little bit unsure what to do.
Have a go, and I will try to get the slides up.
Okay.
What you had before was fine. Yeah.
Like that? Can you see that?
It's fine.
Okay. All right. So thank you very much for watching the video. I'm so proud of that video in particular because it's all the footage was done by us. So we went out to the Pilbara many times with our students, and we shot a lot of that footage, and there's drone footage there as well. So it's really, I feel like an authentic capture of the work that we've done. So my talk today is on AI-driven mobile Medikit for remote health equity. And thank you for the introduction, Brian. So if you are not aware, this is a map of Western Australia, and we at Curtin are located in this pink sort of region here, the Perth metro area. And the region that I work in with my colleagues is up in Pilbara, which is, I've drawn a box around there, so it's this sort of light pink region. This is about 2 and a bit hours flight away from Perth, and it is sparsely populated, and there are really long distances to travel. This is a region that is really rich in iron ore resources and builds a lot of wealth for Australia. However, the traditional owners in this region can be considered some of the most disadvantaged in the world. There's a lot of history around why that is, and there's also other aspects such as these long distances that need to be travelled. There are lots of chronic diseases that are prevalent in the population. So we'd say there's probably about the Australian Aboriginal population in the whole of Australia is about 2 to 5%. In this region, there's about 11,000 Aboriginal Australians, and then maybe about 2,000 in the areas that I work in. So I'm mainly working out of Newman, which is a mining town, and then there's remote communities called Jigalong, Bangor, Coonawarrigi, and others. And these are like 2 hours drive, 4 hours drive, 6 and 10 hours sometimes, and sometimes only accessible by light plane. So these folks that live out in these regions find it really difficult to access ongoing healthcare. There's not a lot of services out there. There's a clinic and an Aboriginal health clinic in Newman. There's a hospital here as well. But in these other outposts, there are smaller sort of nursing posts that are operated by fly in, fly out doctors and nurses. So there's a real challenge for people accessing healthcare. So the way that this project came about was that the WA government put out a competition, a challenge, and it was to improve health equity in the Pilbara using technology. And we were in an amazing position because we have a lot of access to sort of clinical professionals at Curtin, as well as all our technology academics that I work with, as well as having partnerships with big corporations like Optus and Cisco. So we banded together and we put in a proposal to the government. There was 92 entries and we ended up being one of 10 finalists, and we were given a reasonable sum of money to build out a proof of concept over 1 year. So this is just a zoom in of the map I showed you before. So Newman, Jigalong, Bangor, Pumu, Kunawaragi, and you can see in relation to the bigger map. So people need to travel between 140 to 500 kilometres to access care. Often, or very often, these are on roads that are unsealed. So you can see down the bottom, this is what a typical road might look like. And this is a bunch of us traveling in convoy, because just for safety reasons, it's a very difficult landscape to navigate. And the folks that live in the communities, they live a very traditional lifestyle. They're one of the last in Australia to come out and meet Western colonisation. So for only the last 50, 60 years, they've really sort of come into more contact with Western colonisation. They live a very traditional lifestyle. So they'll be moving between their family groups, moving on country between family groups, in order to carry out traditional practices. This may be things like sorry business or women's business, men's business. There's something also called law that takes a sort of a bit of time throughout the calendar, where people need to go off country and do traditional practices. So the folks also have English as their third or fourth language as well. And we observe a lack of infrastructure and medical services that people are able to access. So we did a long amount of consultation. We engaged, these are some of my students talking to Pilbara community. We went out to sporting groups and talked to elders. We talked to the Aboriginal medical services. We talked to Aboriginal health services here in the metro area. We engaged with WACS, so WA Country Health Services. We talked to lots of clinicians and cardiologists as well in the big metro teaching hospitals. So we did a lot of consultation, and I would say, being a computer scientist, I think the technology maybe isn't the bottleneck or the barrier so much. It's actually the need to go out and do all this stakeholder engagement and understand what problems people are facing, and really ask them how they think these might be solved as well. So yeah, this was like a really big learning experience, learning from all these different people. So some of the things that we did learn were that people really valued culturally secure healthcare. They wanted healthcare that was in their language, that really reflected some of their culture. We wanted they expressed the need that trust and building relationships was really, really important. They felt anxious about being away from home. So, for example, being sent to Perth to have renal dialysis was something that was uncomfortable. And we also agreed that a lifetime approach to healthcare was something that would be beneficial to community long term. The other things that we noted was that there is a real shortage of healthcare workers in the region. People often don't want to go up to work in these regions because it is so far away. And also the mining companies do take, a portion of the working population as well. And we also realised that it was really important to upskill and train these health workers to work in these really, these areas that have very specific needs. So together with my colleagues and many, many students, so up to 30 students in AI, cybersecurity, mechatronics, health, and also marketing, business students engaged with us as well. We developed the mobile Medikit, and you can see some proof of concepts we have here. So we've done a few different iterations and taken them all over Australia, up to Singapore even, to demonstrate. but it provides culturally secure healthcare, digitisation and automation of the workflow that's already happening in medical consultations. We're upskilling health workers, and it's portable, modular and satellite connected through our partnerships with Optus and Cisco. So I'll just show you some of the interfaces that we do have on the Medikit. So this is on a tablet. And the idea is that there is something called a 715 health check that Aboriginal patients have access to, but many of the patients fall through the gaps and they don't come in for these health checks. We decided that it would be a really good idea to make this a more culturally appropriate consultation. People could do yarning instead of like a question answer sort of format. And so we built that all into the interface. There's telehealth as well that we can dial in and talk to experts back in Perth. There's also a virtual health assistant for remote workers to ask questions when they might not be like able to have the colleagues around them to support some of the treatment that they're offering. Then we've got sort of a landing screen where the clinicians can ask the patients for vital metrics, so heart rate, ECG, blood pressure, other things like urine testing, also some other tests that we've got on board. And then this is an example of an ECG trace. We've incorporated a lot of AI into the Medikit interface, and we also have like classification of the trace, but also generative AI to tell what that trace means in a more sort of layperson's way of communicating. We've got lots of things around patient education. So because the people are less wanting to speak in English, they prefer to speak in their own language. A lot of the communication is done through visuals and charts. So you may feel, if your blood pressure risk is medium, you might feel like these different conditions. We've got some opportunity. We've been looking at some language translation. There's also lots of metaphors. So we've got a baby kangaroo down the bottom here. That's a metaphor for a heart rate that is weak and irregular. I'm just gonna go quickly through some of these others. These are AI generated health and wellbeing recommendations. So the nurse can select the ones that have been recommended. The nurse can type their own. There's also a QR code and a companion app that the patient can access on their own phone. And I'm going to skip to the next slide. There is also a camera which does computer vision and is able to check on throat conditions, also skin conditions. And then this is a sort of some screenshots of the companion app, so that this is the one that the patients carry on their own phone, and it integrates and synchronizes with the Medikit as well. And then going into care, and I'm a little bit wary of time, so Brian, feel free to jump in. But I did prepare these slides around care. So as the definition says, supporting Indigenous nations with any practices that involve data collection. So that's collective benefit. Authority to control is Indigenous people should have full control over their data collected within their community. And responsibilities, research groups and services have the responsibility to engage respectfully with community. And then ethics, communicating to the public in a transparent manner about how their data is specifically being used. The ways that we do that, so it's not just about like how we store data or how we make data accessible, but it's all the processes around in order to collect that data. So we respect that there are 31 languages in the regions that we work in by the mobs that live there. And then, oops, sorry, had my alarm. And then English may not be the most suitable form of communication. So we often need the help of interpreters to help us do our work. We understand that community-led approaches are priority. So health workers are still guests within the communities. and the Aboriginal people should be prioritised first, so that their assessment should be prioritised first. We understand and respect culture as well. So we understand that Western ways of doing medicine aren't always the best for people, and traditional medicine could be a preference. And we also understand that cultural practices may be important to people as well. So I may, I'm gonna, do I have time, Brian?
Yeah, go for it.
Yeah, so ownership, these are some of the principles around data governance, and so there's the ownership, expression of clear data ownership by Aboriginal people. Control, data is held by authorised custodians. Access, data is locally accessible for the community. And we've, made sure that our data that we've collected is something that can be accessed, and it can be accessed on their own phones as well. Custodianship, the demographic information is applied for collected data sets. We're accountable to Aboriginal people by doing our extensive community consultation. We're amplifying the voice by the encouragement of self-determination, and I perhaps can talk about that a bit more in question time. We're making sure that our data is relevant, so using place-based models of research and service, and we're sustainably self-determining, so recognising and enhancing that skills that already exist in the community should be brought out and used. So going forwards, we've had the support of a big miner give us the loan of a troop carrier. Used to be an old ambulance on a mine site. We brought it down to Perth, and we're refitting it as a mobile clinic, and we're putting the Medikit on board, and we're going to go up and drive into different communities and show them what the Medikit is capable of. And just some photos of some of our consultations. I'll just end on that we didn't win the $5 million prize in August. One of our sort of, other competitors did. But that still means that we're continuing our work. We put so much effort into it that something that we definitely don't want to lose momentum on. And yeah, so I love showing you our work, and hopefully you can see some it resonates with you, and you can see some use in your communities as well. And I just leave you with my contact screen if you'd like to reach out or found any of my work interesting. But thank you, Brian.
Wonderful. Thank you so much for that fascinating presentation. We have a question from the audience. Actually, I have a couple. First, does the portable medical kit require an internet connection?
So not all the time. So we've got an NVIDIA Jetson Orin in the kit itself. So that's able to do our generative AI and all our data processing. That is good for data security as well if we don't want to push some stuff up into the cloud. But we are well supported by satellite connectivity, even in motion, so even when traveling. So we've been able to field test a bit of both.
Excellent. I will take prerogative for the second question. Considering the absolute requirement of stakeholder engagement and consent, how do you explain generative AI and use it transparently to support their choices, their needs, and clinician needs?
Generative AI?
Yeah, so how do you explain this?
Yeah, it's a hard one. So community has said to us that they may have been like the last to meet colonization, but they want to be they want to be the first to be. It doesn't mean they can't be the first in terms of technology. So they're very, very proud. They really, they want to be we want to close that gap in technology, not just all the other sort of social other determinants. So they're actually really for it. It is a bit of, it's a bit, I guess, like interesting for people when they see it, because first, the main way is to do it visually. So generative AI and try and present things as visually as possible. So some of the, I guess what we did was a partnership. So when we were doing the health and wellbeing tips, it was so generative AI does produce those recommendations, but we actually prompted with some of the recommendations that community came up with. So it was a bit of a shared experience. So like they said things like, well, we really love going to collect goanna and emu eggs, and this is a great health and well-being activity. Can we build things around that? So it was a collaborative way of introducing generative AI, because they were adding to the value as well.
Excellent.
Yeah.
We have more questions from the community. Did you integrate some traditional health knowledge, you in fact are talking about this, into the software of the kit? Anything else you want to add?
Yeah, so not so much directly. So we definitely worked with Aboriginal elders that told us about this need, that the community would be interested in their traditional healings. But they would go to their traditional healers first and then be directed to us as a secondary approach. The other ways that we integrated culture into the Medikit is through the 3 stages of yarning. So we had social yarning, clinical yarning, management yarning. So the social yarning is about building rapport with the patient, and it may be things that they're really reluctant to speak about. So we'll need to ask them things around, overcrowding in houses, smoking habits, alcohol, and sometimes there is a feeling of shame that may come with those things. And so we may say things like, do you drink alcohol? What's your alcohol usage like? And we might broach it in a way that it's okay. Like, we also drink alcohol. It's not something to be shameful about. We might have something on our birthday or something like that. So in that way, we're building cultural practices into the way that we're doing our consultations. So it's sort of a balancing between the two. So we haven't really got into the herbal traditional medicines and that sort of thing, but just different approaches, but trying to find a good fit.
And the last question from the audience on this theme is, how do you manage the balance between traditional medicine and Western medicine?
Yeah, I think I probably have spoken to that a little bit already. So but a lot of things that I mentioned before, like the metaphors of the kangaroo, the visual interfaces, but many people are worried to come into clinic though. So the idea is to go out to people and bring the clinic to the community. So I think that's a good sort of medium balance point.
Wonderful. And I think we're going to close your presentation here and move to the panel. So Amir, would you care to join us? As he's doing that, I'd probably introduce myself. I'm Dr. Brian Balson-Stanton. No, join us again. I'm Dr. Brian Balson-Stanton. I'm a researcher in the pragmatics and ethics of AI here at Macquarie University. And my way of exploring this is, how do we understand these textual technologies and create pragmatics and the techniques for use? So thank you both, Amir and Susanna, for some fantastic presentations. I really enjoyed them. We have quite a few more questions going on in chat. This is a panel. This is also an opportunity for the 3 of us to have a discussion around fair and care in AI. I think my first question, and we have about 10 minutes. So my first question is, to both of you, what were the practical difficulties of making your work happen?
Yeah, so I can talk about language translation and some of those difficulties. So, the community really, when we did consultation, one of the really strong, heavy feedback was that they would really love the Medikit to have much more Aboriginal language, and particularly their own cultural group's language in the interface. But this was a real difficult point. One, we could do that one-for-one word translation, but really because of technology, we're able to support things like AI, generative AI language translation. This was a real difficult point because many people are very cognizant that the need comes from community around language translation. So we did do all that engagement and find out it did come from community, but how to formalize that And that would take a long, long time to have that all formally sort of recognised such that we could go ahead and do that work. The other big flag was around using AI for language translation. Because of all the generative AI that has come into view in the last 2 years, many of our corporations, universities, governments, very risk adverse to doing this type of work. So there are no frameworks to be able to do this type of work easily, or people are hesitant. So we were sort of asked maybe not to do it, to do that type of work. We did find some alternative ways of still progressing our technology. So we worked with one of the big tech companies who was already working in this space, who had permission from a different community outside of Australia, different Indigenous community, and we piggybacked some of our work on theirs. So we were able still to make the technological advancements, and later on we'll be able to do that translation into the languages that we're working with in the future.
And Amir.
So I think I can basically again open this in two phases. One is that for our own particular work, the biggest challenge that we will have is a reproducibility of our results by others and reproducing the same experience. And in the kind of back in 2024, which in the world of AI looks like a long time ago, one of the issues was access to the compute and the model and the underlying technology. That's not that much a problem to some degree, as a smaller model now more effective, but we still have a lot of problems around skill gaps, basically for other groups to be able to do these kind of things. The technology needed to be done is much more than just having a kind of prompt engineering for a kind of one LLM. So still there are complexity involved, and making this reproducible required a multiple wiring of things, which is basically the classic problem of reproducibility of science. But in a bigger spectrum, I think in AI and research, one of the problems that we are kind of observing more and more that comes to the spectrum is a re-explainability of AI. So it's difficult for a lot of researchers to kind of explain what happens as a result of feeding the information into the network, getting the result in the other side. It's different from the traditional machine learning techniques, and also those had their own specific audience. Now we have AI walking into the whole different domains, from the health, as Susanna mentioned, to chemistry, astronomy, law, business. So that the prevalence of use of AI now, it's put us to the position that it's almost like everyone should have a bit of background in machine learning and AI, which is not really feasible. So I think that explainability is one of the emerging problems in the research community.
So my second question for both of you, since it doesn't look like chat has raised hands or questions, this is an open Q&A panel, so please drop questions in chat. One of the themes that was interesting that I saw both of you struggling with, or grappling with, let's say, how do we reduce the complexity of access to information? Like, you're talking about publishing your social graph, you're talking about bringing heavy Pelican cases out to country. How do we make this so that it is a tool that is ready to hand rather than present at hand? How do we make this part of researchers or clinicians' toolkit? Amir first, please.
I actually don't have a very good answer for this one, but the closest thing that I can think about this is going back to the concept of augmented intelligence. The concept of using AI by researchers opens whole new possibilities that we didn't have before. It's almost like a lot of people know, almost everyone now can have a smart assistant working with them. An assistant that technically can have access to the entire world of knowledge. And as Brian nodding ahead, is that if it doesn't hallucinate, it might be extremely helpful. But now the access, by itself, it actually provides a good opportunity for accessibility of the results, because it enables the digesting these materials much easier by the researchers. It opens a whole bunch of other problems around the skill sets, not only the skill sets of working with AI, but also skill sets that in future we might lose as a result of using AI. But apart from all of those kind of concerns, AI can open the door for a lot of accessibility that previously was too complicated for a lot of processes to do, or too expensive to run. So from the researcher, putting my researcher hat on, we got a lot of value add coming from AI. A very, very short and simple example. In the past, if I needed to run a certain software on my machine to look at the analysis of a given data, and if I get stuck with running that software on my machine, it's basically I need to block a couple of hours to find out how the issue can be solved, or I get someone from IT or the system, someone else. Yesterday, I was actually kind of had a window of 15 minutes between two meetings. I couldn't get a couple of Docker Compose working on my machine, so I just started to communicate with Cloud Sonnet, back and forth, couple of prompts, and in 15 minutes we were up and running. So this is and assuming in that conversation I had no technical contribution to this except just copying the error, pasting to the AI. AI says type this command, get the command, go back to the computer and type it again. So it make it easier from that point of view to get things running. Sorry, Brian, I think I'm going a bit off the track. Back to you.
It's all good. And Susanna, how do we reduce complexity for you?
Yeah, so it's a great question because it's exactly what we're trying to solve. And I like how you preceded that saying it's really complex, which we found it's massively complex. And, you know, there's so many things to talk about. So even just working with clinicians that may not understand the technical difficulty of what we're trying to achieve, or how fast things can be done, or, you know, that even when we do produce it fast, it doesn't mean that it was easy. Like if we'd done like another iteration, people don't understand that. And I think there's a big mismatch there, but between all different types of stakeholders as well. The idea of the Medikit, and it's, you know, it's really difficult to actually make happen, but the idea is that, you know, you get the box, you're out in the Pilbara, there's no hassles, you open it up and everything's working, and the tablet's working, the interfaces are all working, that you never get an error. It's really difficult to make that happen. But so the vision is that the AI will help. It will pick up things that medicos don't, patterns that they haven't expected. It will pick up insights that you've never come across before. It may translate things that you don't understand. So for example, boundaries of what is considered a good blood pressure may be slightly different in different populations, but the AI will be able to sort of tell you about that. There's also specialist health knowledge that you don't know at your fingertips. Maybe, you know, you may be able to understand from the virtual health assistant. And as well as that, we have the telehealth option as well to reach these specialists that are in Perth. And then we want to do those ECG traces and really understand the classification of them to be able to support diagnosis. So not to make diagnosis, but to support. So yeah, it's a real tricky space with lots of different things to consider. And I think we're only taking like little steps, but the vision is great.
Excellent. So we have a question for the audience for you, Susanna. The current interface for the Medikit is intended for use by a health professional intermediary. Are you considering producing a version that can be used directly by individuals? These could be either people in remote communities or people in larger communities who have other barriers to accessing health information, i.e., is this a generalizable pattern?
Yes, absolutely. So thank you so much for that question, because it does speak to some of the difficulties that we've had in, say, you know, getting people to come on board with our vision. So the people that we're treating are in, you know, they're a small population of Australia. They are not necessarily the people that are paying for the equipment. And it's hard to get like funding and buy-in from sort of that commercialization aspect. So things people have told us are to look at outside at different opportunities. So, for example, we have remote patient care or the aged care sector where we, might need to have this type of device go into homes with clinicians and be able to service their needs. COVID would have been a really great use case as well, having sort of a box that can go out with clinicians or something that people could have had in their own home to collect some of their metrics. But it is a very modular system. So you'll see that we had the blood pressure, the ECG, but we could also sort of diversify into different use cases. So from a technological point of view, that's fine because it's all modular from a software point of view. Sometimes the hardware integration may be sort of the sticking point. But yes, that's definitely our intent because we need funders to fund our work so that we can, expand our offering and then also have money and then go into community to service them.
One more question from audience. How is the data transferred from this mobile kit to another platform for their analysis? And what kind of platform do you use for storage and analysis?
Yeah, so we're still fairly early in our work. We've been going for 18 months or so. This is a real complex question because, for example, in WA, it's not so much a standardized system that the hospitals and all the different clinics have. It's a very complex, different way of doing data integration. So they themselves are not so much standardized. So we also have this problem of how to tap into other systems. We've found an intermediary, My Health Record, which is the sort of government-wide platform that's able to take data in. However, I would say a lot of the data that has been sort of worked with in WA can be paper-based, quite often is paper-based. So it's not a great sort of, it's not sort of, the data isn't transferring really efficiently at the moment as it is. So it's kind of hard to make those decisions. I know that there is a lot of work done at the national level now to look at HL7 and other platforms to be able to standardize some of this though. So probably a little bit early for me to really give you a good answer on that one.
And to end with my final question, I've noticed a great irony in generative AI that normally computers are really, really good at automation of capabilities, and they're not very good at augmenting our own capabilities. And ironically enough, generative AI is absolutely pants at automating things. It doesn't perform judgment particularly well, but it's remarkably interesting in augmenting our own capabilities and making us better where we are better and making us worse where we are worse. Very shortly, because we're running out of time, do you have any thoughts on that tension or dichotomy? Amir first.
I think what you're referring to probably is amplifying rather than the augmenting. So it does amplify what you do, is kind of echoes your own kind of capabilities or capacity or your own skills, if you like, or lack of that. But back to the concept of augmenting of this is that, well, I think this is where the tool set come to play. So I'm just take Susanna's kind of project as example, is that the box, the technology that goes into this and interface is augmenting the expert on the field. I remember from earlier question from Andrew is that can be a direct connection with the actual patient. It can, but I think as it is right now, that augmentation really happens with domain experts. And if you assume that is the case, then the expertise that we have already in place, that's where we actually improve that level of kind of expertise in that group. Now, about the amplification of the problems, you are absolutely right. I don't think they have necessarily any good answer to this. And I think in the social sciences space, that's actually even more prevalent because you can basically generate in a rapid pace what different kind of opinions and kind of fill up the social media in that space quite dramatically.
Yes. And for the last word, Susanna.
I think it's so valuable, augmenting and automating both of them. So you could see in our Medikit, we were doing a lot of digitization of the workflow. So typing in the answers, and I didn't show, but later on, there's like a report generated. So this is something that the health workers really told us that they loved, because this takes away all the mundane work, the work, of data processing and all of that stuff, but they can spend that valuable time talking to the patient instead and doing that real patient care. So I see it as a huge benefit, and also around safety. So making sure that they've completed the consultation properly and they haven't missed anything. That would be a really great way just to do some, double checks. And I feel like the future for AI is just so positive. It's going to bring us so many gains, and I think less, bad things. I think we're just in this stage where we're trying to work things out, and I think, in my opinion, it's a mismatch between the people in technology and the people outside technology that may not understand like how all of these things are playing out. So just like the clinicians did not understand why we couldn't do something that they needed done, I think this is all going to come to a head and people will realize that it'll be okay. I feel like there are so many gains. So the fact that people are saying, oh, AI is not creative or it's not emergent, but actually it makes insights that we can't see and that we probably never see without AI. So I think there's a lot of benefit to AI in the future.
Thank you so much, Amir and Susanna. This was a fascinating series of presentations, and I think this panel at the end got a little spicy. And so with that, we are now coming to the final moments of RDA VP24 Plenary. And it's time to introduce our keynote speaker, Rosie Hicks, the CEO of the Australian Data Research Commons, Australia's leading research data infrastructure facility. Rosie will share her expert perspective on the role of data in emerging technologies, and importantly, will bring us the key announcements and formal close to this plenary. Rosie has 20 years experience working in Australia's research infrastructure sector, with a career spanning every aspect of scientific instrumentation, from product development and technical marketing to managing multi-user facilities. She works across academic and industry domains to drive innovation and research translation. Rosie, the floor is yours.
Thank you, Brian. You worried me for a moment then with that great pause. I thought my internet had dropped out. But before you disappear, can I check that you can see my screen properly?
Yes, we see the slides.
Lovely. Okay. So, of course, it's an absolute pleasure to be here in the concluding session of the RDA Plenary 24. And my huge congratulations and thanks to the organisers and all of the participants in this week's plenary. And the theme, Data for Emerging Technologies, is so timely. And of course, AI, front of mind for all of us, the juggernaut that is artificial intelligence. There we go. Okay, that's working for me. So I am going to pause for a moment to acknowledge and celebrate the traditional custodians of the land on which I live and work, the Gadigal of the Eora Nation, and pay my respects to any First Nations people that we have on the call today as well. As Brian mentioned, my field of expertise is not artificial intelligence, it's research infrastructure. The Australian Research Data Commons, one of Australia's national research infrastructures funded by the federal government under the National Collaborative Research Infrastructure Strategy. So my perspective today is going to be centred around research infrastructure that's needed to support these emerging technologies. What does it mean for our data infrastructure? But before I do that, did you know that IDW 2025 is going to be in Brisbane in October? And over the next few minutes, I will be doing my best to persuade you to come and join us as well. So I am going to start with that juggernaut that is artificial intelligence. And for me today, that juggernaut is in fact one of the Australian road trains. A marvel of transportation. These massive vehicles, some of the largest in the world, can be over 50 metres long. Let's just go, that's how that bit works. Over 50 metres long and with up to 4 trailers. Coincidentally, often used in the outback areas such as the Pilbara that Susanna was just talking about. And the drivers of these enormous vehicles have to be incredibly skilled. If they break down somewhere in the outback, they could be stranded for days. So apparently they can change a tyre on these massive rigs in less than 20 minutes, which is quite a feat considering that that could weigh over 100 kilograms. So that's our juggernaut. Some of the things that we have to think about for our AI juggernaut, the data quality requirements for training robust AI models, the challenges around data bias and representation appropriately, and of course, responsible data governance. They're all things that I'm sure you've all been talking about and thinking about this week. There we go. Which one is it? There we go. One of the things we have to get right as we do this is we have to think about the security of data. Here we have an absolutely iconic Australian attraction, Sydney Harbour and the Opera House. How do I get from data security to Sydney Harbour? Well, harbours need to be secure. And the fun fact for this one is that in 1798, a long, long time before we had the Opera House, Fort Macquarie was built on the site of the Opera House at Bennelong Point. It was demolished in 1901 for the Fort Macquarie tram depot, and of course the Opera House came after that. But it's just going back in history, the security of a harbour, come and see it as it stands today. So that's my move into thinking about data security. But funnily enough, one of my examples goes back to the Pilbara, and Susanna and I certainly didn't plan this between us. But in the Pilbara, every year, industry collects $10 to $15 million worth of environmental impact data every year. And this data could offer significant insights into biodiversity and habitat conditions and provide more accurate regional assessments. But access to the data is limited by legal and security constraints. Similarly, our biosecurity system, with a net present value of 314 billion, faces 25 billion losses every year that could be reduced through better data exchange. And that would enable better informed decision making. And so this comes to the reliance on bespoke data sharing agreements, data exchange processes. Accessing this data is costly and it's slow, it's time consuming, and that restricts the availability. As we move forward, as we're dealing with increasingly large amounts of data, we do have to find ways of tackling that. And so we're coming to the research infrastructure, we're looking at data spaces. So data spaces, those of you in Europe today may be very familiar with them, being used to address these challenges, and we're investigating applications in Australia. So it's a digital infrastructure enabling participants to find, to access, and to use data based on a very particular governance framework. So the vision for data spaces to create trusted, secure ecosystems for data exchange where all of the participants are following these agreed rules. The data providers can set up the usage policies for their data and retain sovereign control. All of these things across research, across industry collaborations, are becoming increasingly important. So now we're going to go next to the sporting capital of Australia in Melbourne. Home, I'm sure you know, to many different sporting events that bring competitors from all over the globe to Australia. So such as the Formula One Grand Prix that was just a few weeks ago, the Australian Tennis Open in January. Competitors from all across the world, not just across the road. But we also have competitions that don't work in quite the same way. We don't need to bring players together. Think about the football tournament. Games are played across the country and the results are combined to give our football league. So the centre image is my football team winning the grand final in 1974. So a lovely photo there for us. But let's think about this in data terms, about the federated machine learning particularly. Only 5% of patients that we have participate in clinical trials, and yet we have electronic data from almost everyone. What if we could access it? What if we could access this vast treasure trove of information and revolutionise healthcare? But the challenge is really, really clear. The patient data sits in silos. It has ethical, privacy, practical barriers preventing us from accessing that data and combining it across institutional, state, national, international borders. And this really does create limitations, as you know, for research. And so we can think then about the federation aspect, and federated machine learning offers a solution. As you know, instead of moving the sensitive patient information to a central location, the federated learning sends the analytical models to the data. Each hospital or registry trains the model locally and only shares the outputs from that model, not the raw data. And so the benefits, of course, are transformative. We can preserve patient confidentiality, we can comply with privacy regulations, and federated learning enables us to leverage these diverse and rich data sources that we couldn't touch before. So the result, robust, representative, and widely applicable healthcare insights to drive patient outcomes. Implementing this, it requires significant infrastructure, software and hardware, particularly technical expertise, cross-institutional collaborations between our data custodians, government agencies, and other stakeholders. It's a frontier technology, immense potential, and something that ARDC has very much front of mind in the upcoming period of time. Just as Melbourne's sporting venues remain separate, but together have a collective world-class sporting culture, that federated machine learning keeps the data separate and creating world-class insights. Now then, as we move on from Melbourne, again, I think Susanna was such a great talk to have before this one. She's covered so many of the things that I was having in my mind, but not enough opportunity to dive deeper into. But cultural data. Susanna mentioned the care principles. So now our journey is continuing across to Wurundjeri country, again in Western Australia. And the background in my slide here is called Meteors. It was created by the Wurundjeri Yamaji artist Margaret Whitehurst for Cetonics. So Cetonics is one of Australia's two national Tier 1 supercomputing facilities in the NCRIS scheme. And the beautiful representation that Margaret has done here was inspired by the stars that shine over the Wurundjeri country in Western Australia's Midwest. And the Wurundjeri people are the traditional owners of the land with the CSIRO Murchison Radio Astronomy Observatory. So this is the site of the Australian component of the Square Kilometre Array. and many of the research insights from the data acquired by the Square Kilometre Array will be processed on this Photonics supercomputer. So it's a crucial aspect that I wanted to bring out when we think about research infrastructure supporting frontier technologies, that need for respectful engagement with culture as well, and Indigenous data sovereignty, recognising the data from Indigenous communities continuing to belong to those communities. We have to have this in the data systems we design with these principles in mind, and ensuring we're not just extracting value, but creating those deep reciprocal relationships that honour cultural knowledge and strengthen communities as well. So some of the research infrastructures, you know, the data security, the need to think about how we do this in a culturally sensitive way. Why do we do it? Well, of course we do it because we want to advance research. We want to understand and protect the wonderful world, to address the societal challenges that are facing us, whether they're health, their food security, their energy, or climate. Now, how could I possibly have my Australian slideshow without including an image of the Great Barrier Reef, one of Australia's most remarkable natural gifts? The Great Barrier Reef is blessed, breathtaking beauty. The one of the world's largest coral reefs, with an abundance of marine life and hundreds of picturesque tropical islands with some of the world's most beautiful sun-soaked golden beaches. Have I convinced you to come and visit us yet? Wonderful natural beauty. Now, we need to look after it. We need to do this research. We can use our high performance compute facilities to undertake this research, but then there's a rub there as well, because there's the environmental impact of undertaking this very, very intensive compute load, and it's something that is growing exponentially. The demand for artificial intelligence, the data processing associated with that, and the data center footprint and energy footprint that's required to deliver on it. So as we try and solve some of these research questions, we are at the same time creating environmental footprints, environmental impact at the same time. So then we start to think about green computing, and this is something I know is front of mind for the Pawsey Supercomputing Centre as they work through where to next with Photonics. And in fact, even Photonics has internationally very significant green credentials as it stands already. But then, beautifully, this takes us back to fair data. The fair data principles, and how do they help us drive down the energy costs associated with processing. So metadata standardization, improving efficiency, clear licensing, allowing broader reuse of computationally expensive results. Version control, really simply preventing excessive duplication of identical data sets when we don't need to do that. So that was a really quick tour, our journey across Australia. I hope I've given you some insights on the things that we think about in terms of the research infrastructure needed to support emerging technologies, from AI's requirements for quality data, secured data sharing through data spaces, the use of federated data assets for federated machine learning, culturally respectful approaches, and the way I think that the important message is recognizing that our data infrastructure needs to evolve to support these requirements. The journey isn't always smooth, like the road train drivers. Sometimes we need to be able to fix problems on the go, but with thoughtful design, with collaboration, we can create research infrastructures, we can operate research infrastructures that enable innovation while preserving privacy, honouring culture, and addressing our most pressing societal challenges. Now, to do this together, of course, we need things like the RDA plenaries. And I know Irina worked very hard to get these slides with the figures from this week. This is an example of how the RDA plenaries support the evolving of data infrastructures. And the statistics for this week, 333 of us attending from all over the globe, working, I think it's the next slide that tells us, in 16 different working groups, 12 different interest groups, birds of a feather, group meetings, as we try and collaborate to address these research infrastructure questions. Incredibly important to join every 6 months in these plenaries. So next year, this time next year, we will be looking at the plenary number 26. Again, will be online and fully virtual. Number 27 will be in London. What a wonderful place to get together. So that will be October 2026. But then, drum roll, please. Well, I'm not going to tell you the survey bit. That will go to somebody else. That's not my slide. Got a few extra ones. No, never mind any of that. Come to IDW 2025 and our next plenary discussion opportunity in Brisbane in October later this year. So congratulations again to the organisers, and my thanks and best wishes to all of you for your attention today. Back to you, Brian.
Well, thanks so much for that, and thanks for that closing. I would just like to thank everyone who attended the conference. That was a wonderful presentation. Everyone should be coming to the RDA plenary in Brisbane as part of IDW 2025. And this is a wrap. So I'll see you all in a few months. Bye.